Let's look at K. Since K was what I left you, remember you may not see me because I need the space. All right, so let us look at K. So I say given. I hate when I click on that. Given K equals -7, -6, -4, -3. And we're looking for the determinant, which is AD minus BC. So it's going to be -7 times -3 minus -6 times -4. All right. So here in the first part, let me take that up a little bit more. We have a negative and another negative. So that will give me a positive. And 7 times 3, that's 21. Now here I have 1, 2, 3 negatives. So I'm going to get a negative. 6 times 4, that's 24. So my determinant, I should be putting this, but my handwriting is.
Your -3.
And give you -3, yes. All right, then for B, we will say the adjoint of K, we say is D, -B, -C, E. So all that's going to happen to get the adjoint.
Sir, before you do B adjointment, do you have to put like non-singular?
Yes, thank you very much. So non-singular.
Okay.
Yes, you're right. Like I told you, when you're dealing with this little thing here, you try not to spell too much because your handwriting, it's not like writing on a board, right? Because you're afraid to break the screen or, or touch something on the screen that will erase everything. So that's what happens. All right, so here what will happen is that the 7 and the -7 and -3 will shift. So I'm going to have -3 and -7 there. Notice that the 6 and the 4 are negatives. So because of the -B, it will change sign. So it's going to go from being negative to being positives. And that's all that happens. All right? So let's look at C now. C is when we're combining these.
Sir, right there, so I get confused.
What?
Right apart, you do that -3 and the 7. How you know if then stay as that and then the 4 and the 6 become positive?
Because all you're doing, a matrix, a normal matrix, K, is in the form A, B, C, D. What the formula is saying is that this goes here and that goes up there. And these, whatever they were, will change from being what they are to the next sign. So if they're positive, they will become negative. If they're negative, they'll become positive. That's all it is saying. That's what the formula means.
Okay, sir. I may think because all of them have negative that top.
No,
all of them when they go to bottom, they have to keep the negative.
No. It is only the formula.
Sir, could you go over it, sir? Can I miss out just now, please?
No, she's saying, why is it that you know that the 3 will be here and the -7 here? And why is it that the 6 and the 4 were negative, but now they're positive? I was telling her, let me rewrite it again for you, Mr. Trotman.
Where I noticed that you got -7 and -6.
Where?
And -9 and -3.
No, this is 4. Sorry that my 4 looks, yeah. What is?
All of them are negative, sir?
All of them begin negative. That's the question. All right.
Oh, okay.
But what I'm telling Ms. Rodriguez is that this is the original here. But the formula for adjoint says that the A will move down here and the D will go up here. And these will have to change. If they are positives, it will become negative. And if they're negatives, they'll become positives. Okay?
One thing I have to ask, you say how you change the A and the D. Do you also have to, by changing them by removing one from down at the top and carry the top at the bottom? when you do the other one, do you have to do that too with them? Or
No,
they can remain the same?
they will remain the same, only the sign will change. Yes.
Okay.
All right, excellent. So let's look at C now. So first C then, we see that k to the negative 1 is 1 over the determinant, which is A, times the adjoint of k, which is the B. So we'll say k to the negative 1 is equal to 1 over the negative 3 times this thing here. So negative 3, 6, 4, and 7. And hence we just multiply. So k to the negative 1 will be negative
7, sir.
negative, yes, you're right. So negative 1/3 times negative 3, negative 1/3 times 6, negative 1/3 times 4, and negative 1/3 times negative 7. Now, I can see that that is, well, negative and negative become positive, so 3/3. Negative and a positive is a negative 6/3. Negative and a positive is a negative 4/3. And negative will make a positive 7/3. I can leave my answer there and it will be correct. Or I can cancel these two at the top, which would be 1 and negative 2, and the bottom will remain as negative 4/3 and 7/3. So either of this, either or, would be the same, would be the correct answer. All right?
Sir, what if I put 3 times 4, which will be negative 12, and then
Well, hold on. What? 3 times what?
3 times 4, which is there.
It's
Negative
1/3,
1/3.
remember. And the 4 is a numerator. This is a 4 over 1. So you can't